All right, two-sample t-test. Form is going to be t equals x bar sub 1 minus x bar sub 2 divided by the square root of s1 squared over n1 plus s2 squared over n2. Very similar to both the two-sample t-interval and the two-proportion z-test in terms of formatting. Differences, we're going from proportions to means. We're going from a z statistic to a t statistic, and we're using the t distribution. Those are major differences. However, a lot of the conditions are the exact same from the two-sample t-interval, as in all of them. All of the conditions for the two-sample t-interval translate to the two-sample t-test. So if you have either been in class for the two-sample t-interval yesterday, or you watched a video on YouTube, the condition checks are the same. So if you would like a moment to recopy those down, perfect. You could also make a note saying that they are the same for two-sample t-interval. You can say C two-sample t-interval. What would you guys like to do? Copy them down? All right, I'll give you a minute to copy those down. All right, so those are condition checks, yes? All right, so we will use those when we do our example. Again, just like the two-sample t-interval, the degrees of freedom are going to be determined by the calculator, and we're going to use technology in order to attain this. All right, this is a free response from a past exam. I just chose this problem. It's a very nice problem to introduce two-sample t-testing. A large pet store buys an identical species of adult tropical fish from two different suppliers, By-Right Pets and Fish Friends. Several of the managers at the pet store suspect that the links of the fish from Fish Friends are consistently greater than the links of the fish from By-Right Pets. So as you're reading these problems, it's good to underline some key info. That's going to help you right here, this statement, oh, not that one, oops, this statement. The links of the fish from Fish Friends are consistently greater than that of By-Right Pets. What that means is that FF is greater than BRP, right? That's what you're suspecting. Random samples of 8 adult fish of the species from By-Right Pets and 10 adult fish of the same species from Fish Friends were selected, and the links of the fish in inches were recorded as shown in the table below. So you have all that stuff right there. By-Right on top, Fish Friends on bottom, correct? Do the data provide convincing statistical evidence? Remember, if we're talking about data providing statistical evidence, what does that mean? We're going to do a hypo test, right? That the mean length of adult fish of the species from Fish Friends is greater than the mean length of that same adult species from By-Right Pets, aka what we've already marked above, right? So this is going to be a one-tailed hypothesis test where Fish Friends should be greater than what? By-Right. You guys with me? All right, let's go through the phantoms here. First thing we're going to do, parameter. We want to test the following hypotheses at the alpha equals 0.05 significance level. I put both parameters up here for you. mu sub b is going to be the true mean length of all adult fish of this species from By-Right Pets, and mu sub f is going to be the true mean length of all adult fish of this species from Fish Friends. It's important to understand how you're going to subtract here. I think we might actually do that a little bit below. We did. All right, so I'll just leave that there. But if we want to make sure that Fish Friends is greater than By-Right, we're probably going to do Fish Friends minus By-Right Pets. So we can go ahead and mark that here. So we're going to do the mean of F minus the mean of B. Could you do it reverse? Could you do B minus F? Yeah, you're just going to switch the alternative hypothesis sign. All right. So the one here that we're going to use for our hypotheses here are going to be mu sub F is equal to mu sub B, and mu sub F is greater than mu sub B, because we suspect that Fish Friends there is going to be bigger or have a mean length greater than By-Right of that species, right? If you did B minus F, what would this hypothesis need to be? If you switch the way that you subtract it. So it has to point towards B, right? So it needs to be less than, right? So if you were to switch the way you subtract, you do mu sub B minus or less than mu sub F. I would say read the stem of the problem to figure out what you're trying to do and make the easiest way to subtract. Like, we know that fish friends is greater than buy right, so we should do fish friends minus buy right and do greater than as indicated in the stem. Does that make sense? Okay. All right, let's go through our assumptions, shall we? We have independent random samples of 8 adult fish from buy right pets and 10 adult fish from fish friends, correct? Each location is independent, so one pet store does not influence or affect the other pet store and the length that they have of this certain fish that is the same species. And here comes the more annoying thing, right? For our normality check, both sample sizes are less than 30. It was not stated that our populations were normally distributed, so we must use technology in order to assess the graphs of both distributions, correct? All right, so we'll do that together just to make sure you have that. All right, we want to go to stat, edit. Can someone give me, clear, go down. All right, can someone give me the links for fish friends? Because we're going to do fish friends, right? So fish friends is which one? Is that the top or the bottom? Bottom. So give me the bottom one first.
3.3.
3.3.
2.9.
2.9.
4.2.
4.2.
3.1.
Okay.
4.2.
Mm-hmm.
4.0. 3.4. 3.2. 3.7. And 2.6.
All right. Let's go over the L2. What we got here?
3.4.
Okay.
2.7. 3.3. 4.1. 3.5. 3.4. 3.0. And 3.3.
Can someone just browse my data real fast to make sure I typed everything in right? Am I good? Okay. So where do we need to go in order to look at these on a graph? Where should we go? Second, y equals to our stat plot. We're going to have two different graphs. One for fish friends, the other for buy right. So do you guys see here that I need two stat plots on? So I need to make sure that the second stat plot is on. And up here, I need to make sure that my first stat plot's on. All right, so in the first stat plot, I'm going to put L1. What does L1 represent? The first list, which is going to be fish friends, right? So the blue graph is going to be fish friends. We're going to go up to plot 2. Oop, not plot 3, plot 2. Oh, crap. Turn that. Let's go over to plot 2. All right, turn that on. I need to switch this to a, notice I'm on box plot with outliers. Remember, outliers for t-distribution is what we're afraid of. So we're going to kind of look at the box plots. I need to change my list here. What do I need to change the red one to? You guys remember how to change it to L2? Blue 2. So hit second 2. And then I'm going to go hit zoom. And then where am I going to go? 9 for stat, right? And this is what you have. Do you have that? All right. Talk to me about what you see here in terms of shape.
Are those approximately
We don't want to say normal for the shape of a single sample. I would say this is roughly symmetric. This one may be slightly skewed, but what's the big thing here? There are no outliers, right? So that's the big deal. So let's go back to said PowerPoint. Not that one, the one that you actually should see, which is this one. All right, so this is what you have, right? So this is what I want you guys to have on your paper. Notice that I put the parallel box plots one on top of the other. You have to label. You guys see where I labeled them over to the right side? So when I did this, I put buy right as red, and I put that on top. I put fish friends on the bottom. It doesn't matter as long as you label, correct? So you can use what you put in your calculator. Up here, I did the length of fish in inches. And then with the statement, the graph of the two distributions are approximately symmetric with no outliers. Therefore, we can assume normality and do t procedures. That is a problem. That is a giant fish. Could you imagine a fish being 303 inches? Divide that by 12. How many inches is that? Or how many feet is that? Huh? It's a 25-foot fish. All the rest of them are like 4 inches. This one's 25 feet. That one must be from like super tropical areas under like in the depths of the sea, and it's like evolved over time. It's like this. Maybe it's the Loch Ness monster.
Actually, would that be one of the sea probably smaller?
That's true. Maybe this thing is like eating killer whales or something. I don't know. All right. And we know here that both sigma sub b and sigma sub f are unknown. So we're going to use the sample ones to estimate. Again, remember, if they give you a graph on the AP exam, should you regraph it?
No.
No, just comment on the graph they give you. Isn't that nice? Okay, so try not to do that. You guys need a minute just to catch up with the assumptions and drawing and labeling and whatever? Okay. Okay, so remember the name of today's test is a two-sample t-test. So we got two-sample t-test. Remember, we typed all this data in our calculator, so we're going to let the calculator do a lot of the work. And remember that today's test is going to be under the same menu, stat, go over to calculate. Did you guys find the button before I went over the button? If you want to make a note in your notes that this is button number 4, the two-sample t-test, it actually says two-sample t-test. So that's kind of nice. You just have to go figure out what it is after you figure what test style you need to use. And go ahead and jot down the test statistic that we're going to use. So here we're going to do f minus b. So we're going to do x bar sub f minus x bar sub b. So we're going to subtract those two means. Divide by square root of the first standard deviation for fish friends squared over that sample size for fish friends plus the second standard deviation squared over the sample size for buy right. And then I'll show you in the calculator what I'm going to get. And we can piece it all together. You guys good? All right. So going over to my calculator again, I'm going to go to stats. We're going to go over to tests, and we're going to go to number 4, right? You could type in the statistics because they gave it to you in the chart, but we already worked at typing in all of that data. So let's go over to data and make sure we have L1, L2. Are they in the appropriate spots where they need to be? Yeah, they are. What sign are we actually using here? Greater than. So it's already picked for us. mu1 is greater than mu2, right? Are we pulling? No. Remember, again, for the scope of this class, we're not going to worry about pulling, so we're going to always say no to it, and we're going to quickly calculate. All right, so this is what you should see here. See if you have the same statistics I do once you use the data piece in your calculator. You guys have the same thing I do? All right, so keep this menu on your calculator. Don't clear it, all right, because now we're going to use it to plug stuff in. Notice as you go down, you actually have the x bars, the s of x's, and the n's. Do those match what you have in the table from the problem? The 3.46, the 3.4, the 0.55, the 0.43, those all match the table? Okay, good. All right, so let's go back here. I organize it there in the table. So now go ahead and plug in all these values. So use those values and plug them in. So just plug in 3.46 for the first one, 3.4 for the second one, over square root of 0.550 squared over 10 plus 0.434 squared over 8. And then remember, what kind of t are you going to get for that? Should be 0.259 for that t statistic. What's the p-value associated with that? If you got 0.6, you did the sign wrong. Yeah. Check to see if you put less than versus greater. Should be 0.3995, right? So what does that mean we're going to do? Regardless if it was 0.6 or if it was 0.4, either case, what is that going to make us think of? Hello? Sorry, you guys were on mute. All right, let's see. If you have a p-value of 0.6 or 0.4, what is that going to make you think of? Good, fail to reject, right? Going to fail to reject. Now up here I was a little fancy. I put this in. You should at least have this piece, correct? Should at least have this piece. I just shaded the normal curve. You can do that if you wish. All right, but definitely to have what's in the red box. So we're going to make our decision, right? 0.3996 is greater than 0.05. Fail to reject HO. So what does this mean? What conclusions can we draw? Since our p-value is greater than significance level alpha, we fail to reject HO. There is not convincing evidence, right? So there is not convincing evidence that the mean length of adult species of fish from Fish Friends is greater than that of Buy Right Pets. So when we compared the two stores, we thought there was a difference in the species because one mean was higher than the other. That claim turned out to be false. Seems to be just natural variation within the fish lengths, according to that species. Oh, sorry. All right. You guys have questions? You good? How similar is this to maybe a 2 proportion z-test or a 2 sample t-interval? There's a lot of similarities. It has its own differences, right? As all, but I will go ahead and put our 9th test up there in just a second. Our 9th procedure. Right? But
How many did you say?
about 14. We're over halfway there. We're living on a prayer too. Yeah. Okay. I'm done.